So slope at any particular time is the instantaneous speed. So that's a big idea there. And we use tangent lines to find the slope of a curve. And this is also described on page 2021. So what's a tangent line? A tangent line is a line that touches the graph at one point, and it says it is perpendicular to the graph at that point. Well, here's a way for you to think about it. If you have a curve here, your tangent point is here at P. This is my tangent line. This line will touch the graph at exactly one point here. Doesn't cut through the graph, doesn't intersect it at all, it just glances. It's like a rock skimming off water. It only touches at one point here. When you find the slope of this line, that will give you the speed at that very moment in time. To calculate the slope, we'll go through this process here. So what you would do is have your distance that you begin. So if you want to consider it this way, draw yourself a triangle to find the slope of the line. You need your rise. So our rise relates back to here. What distance did the object start at? And what distance did it end at? So the distance it starts at is referred to as d1. The distance it ends at is d2. And in this case, if I just read my distances off the graph, I have to take d2 subtract d1. That'll give me the height, the 140, so which will be right here. Subtract 25. That gives me the change in height. So what's the height here? That's 115. Over how much time? From 20 seconds up to 40 seconds. So time 2 and time 1. So time 2 is always your last time. Time 1 is the earlier time. We will subtract those two values. 20 seconds have passed. So what we're finding is that in 20 seconds, the height of the object, or distance of the object, changed from 25 meters up to 140 meters. And then the speed at that very moment is 5.8 meters per second squared. So what I want you to do is to have a look at the YouTube clip that's posted here. And that clip is listed on the course website under this week's notes. So you'll see a link there for instantaneous, for tangent lines and instantaneous speeds. And it'll show you how to draw these lines and how to calculate that. And if you have any questions on it, I'll go over it with you. So once the slope is found, we will have the speed of that at that very moment in time. So the question that comes up then is, what shape would you have if you went to plot a velocity time graph? So what I'm going to do is give you a stop now, and you should review this video clip, and then we'll move ahead with the other slides. Alright, now that you've reviewed that clip, we'll move ahead to the next slide. And here you have to calculate the instantaneous speeds at 2 seconds and 4 seconds. First, what we'll do is draw on our tangent lines, and I've already drawn in one tangent line here. So at 2 seconds, I'm going to draw a line that hits this point, this part of the graph at one place, and then I'll continue it on. When I continue the line on, I could have stopped here, there, or I could keep the line going, but I decided to end the line right here. And the reason I stopped the line there is that I know what time this is. This is 1, 2, 3. This will be 3.2 seconds. So it's a value I would know. If I stopped here and then tried to get this time, then I'm estimating. So stop on a grid line on the graph so you know exactly what the values are. And then and I also know the ending distance for this line. If I look across, it would be 8 meters. So your instantaneous velocity is your change in distance over your change in time. So your d2 subtract d1 over t2 subtract t1. So my ending distance here is 8 meters. And if I just went down and I look across, the distance I'm reading here is 0. And the ending time is 3.2 seconds. Subtract. So this is my T2. And my T1, if I follow the line back, that hits. And this is my T1, 1 second. So it will be 8 meters divided by 2.2 seconds. That's going to give us 3.636 or 3.6 meters per second. Now what I want you to do, well, you should have done that one on your own and checked after. What I want you to do is calculate for 4 seconds. Okay, now that you've done your part there, I'll finish here. So I've drawn in my tangent line. And my tangent line at 4 seconds, so that's my point. I've extended it up to here and down to there. So to calculate slope, or instantaneous velocity, change in distance. So remember that triangle delta means change in and change in time. So d2 subtract d1 over t2 subtract t1. So my d2 would be here. I look across and I keep going. So 30, 32, 34. My d2 is 36 meters. I'll just continue that up here. 36 meters. My d1, so I continue the line down. If I wanted to, I could have picked it here. That's another point I could have used, since I know both values, but I just continued it down. And my distance, when I'm at this point I look across, is 0 meters. And now my change in time. So 4.2, 4, 6, 8. So 4.8 seconds. Subtract 2, 2.2, 2.4, 2.6, 2.8 seconds. So 36 meters. Subtract 2 seconds. Oops. Equals 18 meters per second. So that's my velocity here. And if I compare that back to my first one, much faster. Okay, about 5 times faster. And now what I'd like you to do for homework is to finish example 3a. So use tangents to find the speed at 0, 2, and 4 seconds.